In this last example we're going to look at together, we have the differential equation as a function of both x and y. Once again, you might want to start by determining where it is that you're going to have horizontal slope cuts. So if you think about how the x and the y values have to be for this differential equation, in order to come out with a slope of 0, the x and the y will have to be the same value but opposite sign. So for instance, down here at 1, -1, that's where we're going to have a horizontal slope cut. At 2, -2, we're going to have a horizontal slope cut. Here at the origin, of course. Then over in the second quadrant at -1, +1, -2, +2. That's always a great place to start. Here on out, it's simply a matter of substituting in your x and y values as you go from one point to another. Some people like to set up a table of values to do this. Some people just like to do it in their head. You can really do it however you want. Some people like to make little notes on the side as to what ordered pair they're using and what they get as the slope. I'm going to start over here in the second quadrant right here at the point -2, +1. So your differential equation simply calls for you to add the x and the y value. So if I'm working with the point -2, 1, and I add those together, I get a -1. So I need to line up my straight edge so I have a slope of -1. So down 1 and to the right 1. And I'm just going to go straight down that column where x is equal -2. So over here at -2, 0, my slope has to be a -2. So I can line up my straight edge down 2 and to the right 1. Moving into the third quadrant, the point -2, -1. Now I have a slope of -3. So maybe I need to go up and over to the left to line up my straight edge. So up 1, 2, 3. To the left 1, I can line it up there. And then finally down here at -2, -2, I have a slope of -4. So I can line it up 4, 1, 2, 3, 4, and to the left 1. If I go to the right then, maybe starting up here at the point -1, +2, adding those together, I now have a slope of +1. So I need to line up my straight edge to have a slope of +1. I can go down 1 and to the left 1. So there's my slope cut for that one. Here on the axis at -1, 0, I have a slope of -1 when I add the coordinates together. So I can line it up to go down 1 and to the right 1. At the point -1, -1, I'm going to have a slope of -2. And then finally at the point -1, -2, I'll have a slope of -3. Up 1, 2, 3, and to the left 1. And you pretty much just keep going until you have all the required points on the slope field graph filled out. Continuing here on the y-axis, if we start up here at 0, 2, my slope has to be a +2. Right here at 0, 1, I'll have a slope of +1. I already had my horizontal slope cut at the origin. Now moving down here to the lower y-axis at the point 0, -1, now my slopes turn negative and I have a slope of -1 and then finally a slope of -2. Moving over to the right once again up here at the point 1, 2, that gives me a slope of +3. So I can line up my straight edge down 1, 2, 3 and to the left 1. At the point 1, 1, I have a slope of 2. Right on the axis at the point 1, 0, I'll have a slope of 1. And then here's my horizontal one. And then down here in the fourth quadrant at the point 1, -2, now my slopes once again turn negatives and I have a slope of -1. Let's do one more column. Starting at the point 2, 2, adding those, I have a slope of 4. 1, 2, 3, 4, and down this way. Here at the point 2, 1, I'll have a slope of 3. 1, 2, 3. Again on the axis at the point 2, 0, I'll have a slope of 2. And then here at the point 2, -1, I have a slope of 1. You'll notice some characteristics. Notice up here in this upper right corner, all of your slopes are positive, whereas down here in the left corner, they're negative. The fact that you see right here how you have like these almost in a perfect line right here, that's what we refer to as a slant asymptote. So this graph, were we to sketch a possible solution curve for it, probably be asymptotic to here somehow. I now ask you to go ahead and try the others on your own. The solutions are provided for you online.